Hello and welcome to the StudyCIMA analysis of the August 2017 management case study. My name is Hashan Madushanka. I'm the lead tutor for StudyCIMA. I've been coaching students globally ever since the case study examination started, and I have covered all the case study diets until date. Right, so let's see what we got. We have a company named Aurora Automotive. So as we are aware, automotive refers to anything relating to vehicles. So this is probably a vehicle manufacturer or maybe some company that manufactures parts of a vehicle. Let's find out later on. So we have 25 pages. Okay, first of all, the job description is provided, and as usual, as like every other management case study, you're the financial manager. You report to Jens Snyder, a senior financial manager. So most of the emails at your exam you can expect from Jens Snyder, the senior financial manager, and who in turn reports to the finance director. Right, so with my experience, most of the previous case studies, the financial manager had to immediately report to the finance director. But in this company, there is another link in between, the senior financial manager. So seems like this is a tall organizational structure. Probably more information on that is given later on in the pre-scene. Your primary responsibilities are associated with management accounting. So we are referring to mainly the areas tested for P2. This means that you often have to liaise with colleagues from the treasury and financial reporting functions. So treasury and financial reporting is in line with what you learn for F2, and also from other functional areas including sales, human resources and operations. Of course from E2. So as you see, although you're the finance manager, your job role is not restricted to finance, which means at your exam you can be tested from a very broad number of areas. So keep that in mind. However, the main trigger is generally from P2. Now, if you take a task at your exam, I'm sure most of you would have seen how the exam looks like. You would have a task generally mixed from two subjects. And sometimes certain questions you may not be able to figure out the exact area in the syllabus, and you don't have to worry about it, since this case study simulates the actual business environment that you're working for, and everything that happens in the business, well, you can't necessarily connect it to every area of the syllabus. Sometimes you need to use your common sense and then answer the question. Right, so as the financial manager, you have a job role such as helping out with investment appraisal. Treasury refers to financial management, maybe advising on the sources of finance. Financial reporting, that's referring to the accounting treatment on certain items, maybe consolidation and the accounting standards that are covered in F2. And apart from that, you would also have to deal with, say, relationship management, project management, of course, crafting the strategy of the company, and probably advising on human resource related issues. Operations management. Now, operations would be very probable, since we are looking at an automotive company where we can expect a high level of automation and process management. So as the finance manager, it's very important for you to have a broad knowledge on all of this, and more than the knowledge, it's the application that matters at your management case study. Remember, your operational case study had 64% technical, but the management case study has 39% technical. So the technical component reduces and the application has to increase. So as you keep practicing exam related questions, maybe you can use the study material provided by StudyCIMA. That will definitely help you in familiarizing yourself with the exam. Now that this is especially important for any gateway students, any students doing the MCS through the gateway route. It's very important for you since you don't have prior experience in the case studies with CIMA. Alright, so moving on, we are looking at some details about the automotive industry. Of course, it's very important for you to know about the industry you're dealing with. Now, you can get your hands on our industry analysis that's based on the automotive industry. The automotive industry has always been at the forefront of technological developments in manufacturing and in commercial business practices. So I need not explain you the importance of the automotive industry since most of the traveling has to happen, and this is very important in the commercial world. Now, if you take in terms of technological developments, we have seen a lot of transformations in the vehicle specifications from the Second World War time, and then 70s, 80s, and of course the advanced vehicles you have today, such as electric vehicles and hybrid vehicles, well, of course, self-driven vehicles and so on. So the technological development is extremely crucial for any player in the automotive industry. For example, it has led in the development of automated manufacturing processes and of globalization in both manufacturing and marketing. Now, traditionally, of course, most of the vehicles were manually made. However, companies such as Toyota and Ford and so on, they introduced automation to a great extent, which means the production process became much faster. And in terms of globalization, this is referring to the import and export of vehicles throughout the world. The country doesn't have to be using their own vehicles, they can always import. And certain countries, they have, or they are specialized, they have the competitive advantage. We can, of course, apply the Porter's diamond theory in this case, something we can use to analyze how good a country is competitive in terms of an industry. Marketing wise as well, so you have international manufacturers marketing throughout many countries. For example, if you take the product Toyota, or if you take Toyota vehicles, it's basically available in almost every country, and most people know this. Most people know the brand, they are aware of the brand due to good marketing. At the start of the 20th century, when industry first came into existence, manufacturing was heavily dependent on skilled labor. Alright, so as I mentioned before, most processes were labor intensive due to the lack of development in technology. This approach quickly gave way to the use of production lines to improve efficiency and lower cost. Right, so the process was rationalized by introducing a production line, which means they've, according to industrial engineering, they found probably a faster way or probably a more efficient way of getting things done, and that is how the production line uh, came into play, right? And of course, when things are rationalized, definitely the cost would also reduce, and they would have been looking more at batch production. These permitted assembly to be broken down into a series of tasks, none of which required a great deal of skill or training. So we are looking at breaking the entire process into different parts and maybe deploying employees who are specialized in a particular task. and also certain assembling processes, certain fitting and so on could have been done through machines rather than using employees. Each worker would fit a specific component to each car that passed on the production line on a repetitive basis. Now, when you look at the term repetitive basis, this should remind you of an area that you learned for P2, something referred to as the learning curve. Now, employees that are involved in the process, in a particular process, who repetitively conducts that task, well, the learning curve can definitely apply. And for the learning curve to apply, they should have standard products, and most probably the cars used these days, there is a certain element of customization, but most of the processes would be repeated. So, to what extent does learning curve apply in Aurora Automotive? We need to think of that as well. Moving on to the next paragraph, the introduction of more efficient production methods reduced manufacturing costs to a level where cars and other vehicles could be sold to the mass market, and so the automotive industry grew to become a dominant economic force in many countries. So this reminds me of the orientations that we have studied in our previous level, where we looked at marketing orientation, sales orientation, and so on. So this is referring definitely to the production orientation, where companies mainly focused on making the production methods more efficient in order to drive the cost down. And of course, due to these costs coming down, companies were able to sell it at a lower price. That's what I have highlighted here, saying sold to the mass market. And due to this, people with even middle income would have been able to afford vehicles, and more businesses started using vehicles, which means the demand substantially grew. And when the demand grows for a particular product, this product becomes a very important part of the economy, since it influences a great deal into the aggregate demand of a country. Individual vehicles comprise literally thousands of components, and many businesses were created to supply the major car makers with parts and material. Right, so as we know, a vehicle is not a very simplified product. Well, you have so many components that are required, and these components have to be of very high quality as well in order to assure safety and also to satisfy the psychological need of the customer in terms of looks and so on. Now, due to this, many companies saw opportunities and they got into the industry by producing parts and material, which of course the car assembly companies can purchase from them. Early production lines were highly efficient, but they offered limited flexibility. Each production line was designed for a specific model, and there was little or no scope for different versions of a particular car or to add options or accessories during production. So the first thing that came into my mind when I read this is the flexible manufacturing system that's used by most automobile companies, especially Toyota. So the production lines, the setups were focusing only on one model, but nowadays with a small changing to the programming, the assembling methods and so on, within a very short time you can switch from one product to another, which of course you can identify as a switch option when it comes to real options in investment appraisal. So that flexibility was not there traditionally. The latter part of the 20th century saw a revolution take place on three fronts. Firstly, there was a move towards modular component subsystems. Right, let's look at what this is. Specialist manufacturers offered sub-assemblies such as engines, gearboxes, braking, electrical and steering systems. So we are looking at different companies specializing in the components of a vehicle, as I mentioned earlier. They would have seen the opportunity, since it may not be viable for a car assembler rather, to manufacture all the components. So you would rather focus on your core competency. Reading on, these could be mass produced in order to create economies of scale, and the resulting assemblies could then be shipped to the factories where they could be added to the assembly process. This led to a shift away from wholly national car manufacturers to a more global outlook. Now, if you take most of the car manufacturers, they import products from various countries. If you take, I'll give you an example, little beyond the scope. If you look at the aircraft company Boeing, they are looking at they are looking at suppliers from over 30 countries, and easily over 50 suppliers contribute in the build of an aircraft by supplying material. So this is definitely a trend that you see in the modern world automotive industry. For example, a European manufacturer might use a braking system imported from a manufacturer in Asia and an audio system from a different manufacturer in the USA. Now, the trend is that most of these components, countries such as China would have a competitive advantage, and you see many car producers importing from Asian countries. Secondly, manufacturers started to share common components across multiple models. Let me go ahead and highlight that. All right. For example, a manufacturer might create a floor plan rather, which is essentially the base for the car's body. Now, this is also referred to as a car platform. A car platform where the processors and all the parts may be common, but with certain modifications you can look at different models, and a car platform may be shared by various manufacturers. They might invest in the research of a platform together, and once it is done they might acquire the platform and go ahead and produce models by themselves and sell, of course, individually. That same floor plan might then be developed into a family hatchback, small delivery van, and also a sports car. Each model would have a body suited to its role, as well as being fitted with an engine and other components that offer the appropriate level of performance or economy. Despite the differences, it would be possible to use common components in several different models of the car, thereby creating significant economies of scale. Right, so that's another change that has taken place. Move on to the next para. The sharing of components extended to collaborations between different manufacturers. Now we see many companies coming together, Asian companies and European companies, for example. For example, it became common practice for two or more manufacturers to agree to collaborate on the development of the basic structural elements of a car, along with major elements such as an engine and gearbox. Now, certain car manufacturers, they have specialized, or they are good. They have a core competency with regards to a certain area, maybe in the production of engines, whereas another manufacturer might have a different core competency. But if they bring this together, they can of course produce a much better quality product, and of course save on the cost that is invested on research. So as you see, due to this reason, we find car manufacturers collaborating with each other on research and development. Each manufacturer would then design the bodywork to create a different vehicle based on the same basic design using common parts. Now, of course, the usage of common parts would be again an advantage, since companies can buy in bulk and that will grant them discounts. And further, it would also be an advantage to component manufacturers, since they can stick to a smaller range, which means they'll be able to uh, produce in a mass scale that will lower cost. And as you see, it's a win-win situation where The component manufacturer also drives down costs, and that could be passed on to the car assembler by means of bulk discounts. The resulting vehicles were then sold in competition with one another, albeit with both manufacturers benefiting from the economies of scale associated with manufacturing major parts in bulk. So this is definitely a sensible move when it comes to the automotive industry. Certain initial aspects, both companies would do a common development, and then they would go in each other's ways as competitors. So overall, it's a win-win situation. As I mentioned, both companies would benefit. However, after deciding the final model, the success of a company depends on how they attract this model to the customer, how well they market, and so on. Right, then we are looking at the third change, the rise of robotics in the production process allow for many of the simple, repetitive, mundane tasks on the production line to be automated. Now, automation is of course a good thing for any company since it drives down cost. However, there is also a humanly aspect here since you might have to make employees redundant, and that would cause a bit of an issue. And also the initial investment when it comes to introducing robotics could be very high, although the maintenance cost might be much lower than having to employ humans, of course. Robotics also allow for far greater precision than had been possible when using human operators. So we know that robots are programmed in advance, which means it will be the exact same scope of work that will be conducted from one unit to another. However, in the case of people, there can be slight variations, although learning curve would not apply for robotics. It would only apply if a human works in the process. So although with the precision being lower when humans are used, the learning curve will also come into play, which is of course cannot be expected from a robot unless of course you upgrade the machine. For example, a robotic welder could place the spot welds used to fix body panels in place more accurately, allowing for a stronger join and the possibility of a more attractive finish. Right. Robots also offered much greater flexibility. Now we know that when it comes to humans, there is always an emotional aspect, a psychological aspect. You can't expect a person to work continuously for say 20 hours a day. But robots, on the other hand, they will not complain. Right? So you program them, you put them to work, and until you switch them off, they'll just keep on doing whatever you have programmed them to do. Robotic production lines could cope with different versions of the same basic car to be produced in a single run without interruption or retooling. Each car was given a unique vehicle number. The production line tracked each vehicle individually. So this is the automation getting advanced. For example, engines would be brought to the production line in an automated sequence so that sports models were fitted with high performance engines and economy models with a more fuel efficient alternative. Right, so we are segregating the engines according to each car model, which would easily be possible as long as you program the robotics. Now this is definitely possible with humans, although it can be a little more time consuming probably. The system could also cope with optional extras and different finishes. Right, so we are looking at customization. For example, the customer could order an accessory that could be fitted on the production line with the robots being programmed to select different parts as necessary. Right. The automotive industry was an early adopter of many advanced manufacturing techniques, including just-in-time and quality circles. Now this should remind you of the revolutionary company that introduced just in time, which is of course Toyota. And also you can draw out the knowledge that you gain for E1 in operations management. We looked at lean manufacturing, total quality management, and techniques such as that. So it would be useful if you know about these at least at a basic level. Now just in time and TQM of course is present for P2 as well. But just a sneak peek into lean manufacturing would of course come in handy at the exam. The complexity of the manufacturing process has made their implementation a challenge, but the industry has always placed a great deal of emphasis on economy and efficiency. So these relate to saving down or saving on the cost and time. Now initially the concepts would have been a little difficult to implement, but you make mistakes, you learn from it, you make mistakes, you learn from it, and ultimately you would engineer a proper process in order to get the ultimate objective. This high level of automation has not eliminated manual labor from the industry. It has always been necessary to employ human operators. Right, so as we know, there are certain jobs that machines cannot replace. Let's look at some of the examples. Maintenance. Some robots have self-test and self-calibration routines, but there will always be a need for engineers to repair broken equipment. Now, a standard process such as assembling a car can of course be automated. However, with regards to repairing equipment, it would not be a standard process since different equipment can face different damages. So you always need a human mind to understand what exactly has happened and what needs to be done. Then production and control. Some production lines can be reconfigured to produce more than one model. This usually requires the line to be stopped and the equipment reset manually. Right, so we are looking at a new machine setup where it's reprogrammed to suit the next model. Such changeovers are generally kept to the minimum by having fairly long production runs for any given model. Right, so the batch production would be arranged in such a way that the entire demand of one model would be finished, and then you move on to the next model, since changing the specifications of the production line would be time consuming and could even be costly. And this would also mean that the need for human operators would reduce since the number of changes would not be very high. And the third event, unanticipated events. People can be tasked to new roles far more quickly and easily than machines, thanks to our brain, which machines don't have. For example, an additional quality check may have to be introduced if there are concerns about a batch of parts. Right, so if they feel suspicious about the efficiency or the effectiveness of the production, they would need to conduct a quality check, and such quality checks have to be done by a human. Also, certain tasks may benefit from a human input. For example, a final product inspection may be more effective if it is conducted visually. Right. Then the next one, complex tasks. It may be more cost effective to carry out certain tasks manually. For example, it may be cheaper to have human operators work on some low volume models than it would be to program the production line. Now that makes sense, since if it's a model that is not sold in large quantities, then the amount of revenue that we receive to break even would be lower. And introducing automation could initially be costly. So doing a cost benefit analysis, companies would have realized that it's much better to have people working on this. Although the Although the salaries are a recurring expense, on the whole, it might be much cheaper than getting a machine down or getting the machines reprogrammed to suit this model. Okay, moving on. The changes in the automotive industry have not solely been driven by changes in manufacturing technology. In the first half of the 20th century, most industrialized countries had their own automotive industries, with cars being designed to meet the tastes of local consumers. So when cars used to be a luxury product, most companies used to custom make the car. Then again, Ford came into play, and Henry Ford, of course, mentioned, I'll produce any car as long as it's black. So in other words, I would only produce one model, and that black in color. So that is how the Model T came into play. And that is where, to a great extent, batch production was introduced into the automotive industry. So Henry Ford got into a blue ocean, something we call a blue ocean, where within an industry you create a different segment by doing some value additions. Exports were primarily to countries that did not have their own local producers. Most of the, of course, Asian countries and African countries, of course. Manufacturers in Asia started to export more aggressively in the 70s and 80s and started to compete with local manufacturers in their home markets. So this is the process of globalization coming into play, where the barriers between countries reduced and products of one country were easily available in most other countries, and producers in a particular country didn't only have to compete locally, but they had to compete globally. Consumers became more willing to buy foreign cars, and manufacturers started to develop cars that had the capacity to appeal to a more global market. So when you are dealing with many countries, it's very important that you understand what uh, different people want. So accordingly, you need to cater your products in such a way that it convinces the people of these different countries to buy your product, right? That led to a process of consolidation in the industry, with major manufacturers merging or being acquired. So I hope you all know the difference between the two. Merging is where two companies coming in together. Acquiring is where one company, probably in a forceful manner, acquiring shares of another company. Acquisition can also be one company acquiring another company that is not performing well in order to turn it around. So such moves definitely results in economies of scale and, of course, maximizing market share, something we refer to as synergy. The common saying that says 1 plus 1 is greater than 2. So these developments in the industry, the consolidations, would have definitely resulted in synergy and economies of scale. This process was encouraged by the development of cars for the global market. Car makers aim to develop models that could be sold around the world. Economies of scale were often maximized by having a single factory make all cars of a particular model using parts sourced from around the world. Now, having multiple factories can be costly in terms of overheads. So having a single factory can save a lot of overheads in that case. Now, when it comes to the parts, these are bought from all over the world. Of course, there's a transport cost involved, but the transport cost may be much lower than the benefit you get from the lower prices. So that would have been the reason for companies to purchase most of the parts rather than produce it in-house. Now, when it comes to purchasing parts, something very important would be the quality of the parts. See, if you're producing the parts yourself, you have total control over what is happening. But when it comes to purchasing, it's of course produced in a different factory, and all you see is the final product and not how it was produced. So it's very important that you do thorough inspections before taking these parts into the production process. Major manufacturers located their factories in countries that minimize total costs. So generally in countries where the labor is cheap, such as China and India, right, most Asian countries. For example, European manufacturers built factories in Central America in order to take advantage of low wages and operating costs, and also proximity to the wealthy North American markets. So when producing vehicles, there are two things you need to look at in terms of location. One would be, of course, to save the cost, and this is generally influenced by factors such as low rent, low wages, and the second thing would be the closeness to the final consumer. So if the factory is located near the target market, that would of course cut down the delivery expenses. But according to my opinion, the first reason would be more important, since with the developments in vehicles and other logistics services, transport costs have come down, right? So the main emphasis should of course be on the production cost, driving it down and then probably passing it over to the customer by means of lower prices. That's of course for economy models. Now, so far we haven't come across any details of the company. So there you go. So now let's discuss about what we can expect at the exam, the company that we are working for. So many pages are included in the pre-scene covering information about this. So of course let's start our discussion.